Tonight we're going to be modeling up the matching parts core. To get there, I can go to the module. So under the project, I'm on the home page, go to the project list, module 4, matching parts. And we're looking at the matching parts core project, or matching parts core portion of the matching parts module. So I'll select the matching parts core discussion. Takes me into the project page. I have a drawing. I have several videos from the previous semesters. So if for whatever reason you want to revisit this project after tonight, you can see the videos that were made from the two previous semesters with this particular project. Same project done with the two previous, or done during the two previous semesters. We'll be referencing the modeling section of the project page. We're given some basic instructions. And then you'll see that we go into the toolpaths. I don't think we'll get into the toolpaths within this lecture, but we definitely will next class. So I'm looking at the drawing. And what I'm going to do is I'm going to draw a rectangular shape. And I'm going to use that for construction purposes. I'm going to draw a rectangular shape that measures 4.75 by 2.75. And then I'll draw some circles on the ends or on the corners of that construction rectangle. They'll have a radius value of 0.6. And that's how I'm going to start this project. I'm going to start by modeling up the arc profile. A little bit different than a little bit different than how I went about modeling up the matching parts cavity. You can do it several different ways. When it's all said and done, the final result, if it's correct, that's what's important. So I'm going to start by creating some construction geometry, and then we'll start building this part. We're going to build a 2D representation of the part. We're going to dimension it to verify that it's correct, and then we'll create the 3D model from the 2D representation. So I'll go into Mastercam. I have a brand new session of Mastercam opened up. I'll minimize any manager that might be visible. I'll go to View, and then I'll select whatever's blue, and that minimizes it. If I ever need to get them back, just go to the manager section and click on the manager. If it's highlighted blue, that means it's active. So deselect it, it goes away. I'm going to draw in a construction rectangle, and I'm going to center it on the origin. I'll go to wireframe. And before I create the geometry, let's go to home. Make sure that your wireframe color is something that you can easily see with your background color. So I've got mine set to green. I'll go to wireframe. Under rectangle, you'll see a small arrow, select it. I'm using the rectangular shapes tool. Once again, the construction rectangle will measure 4.75 by 2.75. I'm using the default settings here. For the origin, I'll set it to center. For the width, I'll type in 4.75. If I hit the tab key, it now highlights the height field. I'll type in 2.75. And then when I hit enter, if I move my cursor into the graphics area, you can see a preview of that rectangular shape. I'll let my cursor lock onto the origin. When I see it lock into position, left click. And from here, I'll double check the values, 4.75 by 2.75, and then I'll select OK to exit the tool. I'm now going to draw in 4 circles with a 0.6 radius. That information is coming from this dimension on the drawing. So draw in 4 circles, 0.6 radius. Let their center points lock on to the outer corners. So I'll go to wireframe, circle center point. For the radius value, 0.6. I hit enter. And then to create multiples, I'll lock down the value. And then when I move my cursor into the graphics area, you'll see a preview of that circle. I'll position my cursor on the outer corners. When I see it lock into position, I'll left click, and then I'll move to the next one. Once I create the 4 circles, I'll exit the circle center point tool. I'll select the green check. And this would be a good time for me to save my work. So File, Save. I'll navigate to my working folder. So inside of the class folder, MACT 160 Fall, I'll create a folder called Matching Parts Core. So create a new folder, right click, new folder, Matching Parts Core. I'll hit enter. And then I'll open up that folder and I'll save the Mastercam file with the same name. Matching Parts Core. I'll select save. And when I do that, if I look at the top of my screen, you can see the file name and where the file is located to. I'll now go back to the drawing. I'm going to draw in these tangent arcs. I've got a 9-inch radius. I've got a 14-inch radius, a 10-inch radius, and I have another, I'm not seeing it, but we're going to make it the same as this one over here, 14. Yep, right there it is, 14. I'll start at the top with the 9-inch radius, and then I'll work my way around. So back to Mastercam. I'm going to use the arc tangent tool. Go to wireframe, arc tangent. I'm going to set the method to 2 entities. For the radius, type in 9 and hit enter. If the radius is too small, it'll throw an error. I'm going to select this circle at around the 2 o'clock, and then I'll select this circle at around the 10 o'clock. When I click it the second time, or when I select that second circle, it's showing me a preview of all circles or all arcs that have a 9-inch radius that could be tangent to both of these items. Because of the way I selected it, it thinks that I want this one, and that is correct. So I'm going to select the one that I want to keep. It doesn't matter if this one is solid and this is the one you need to keep, just click the one that you need to keep. Double check the radius value and then select OK, create new operation. This will finalize the creation of this arc. You'll notice that it's blue or a light blue. It's still a live entity. So double check the value, 9-inch radius, and then select OK, create new operation. I'll go back to the drawing. I'm now going to create the 14-inch radius arc. I'll create one here, and then I'll create one over here. In the radius field, type in 14, hit enter. I'll need to select the lock again. Yours might still be locked. And actually, yeah, I'm going to lock it down in this case because I'm going to create 2. I'm going to select the top right circle at about the 2 o'clock. And then I'll select the bottom right circle at around the 4 o'clock. Select the option that you would like to keep. Select OK, create new operation. And then I'll do the same thing or something similar on the left side. I'm going to select the upper left circle at around the 10 o'clock. And then I'll select the bottom left circle at around the 8 o'clock. And then select the option that you would like to keep. And then select OK. I need to create one more tangent arc. This time the arc will have a radius value of 10 inches. Set the radius field to 10. I'll now select the lower left circle at the 4 o'clock. And then I'll select the bottom right circle at the 8 o'clock. Double check the drawing. This is the option that I would like to keep. So I'll select the option that I want to keep. And from here, I can exit out of the tool. Once again, double check the value, make sure that it's correct, and then select OK. This would be a good time for me to save my work. So I'll go to File, Save. How's everyone doing?
Good.
Nice. The next thing we'll need to do is trim back the circles. And we're going to use the trim 3 entities method. This is probably the better of the options that are given to us inside of Mastercam. You can get other ones to work, but this one works the cleanest. It doesn't leave overlapping entities. It doesn't leave small segments that need to be trimmed again. So to find the trim 3 entities, go to wireframe, trim to entities. For the method, set it to trim 3 entities. And for the type, I have trim selected. So type trim, method, trim 3 entities. Now the way this tool works, you're going to select the 2 items that you're trimming to. So I'll select this arc. I'll select this arc. They're not being trimmed. We're trimming to them. And then I want to select the part of the circle that I would like to keep. I'll select this circle right here. And you see how it highlights? That's indicating to me or telling me that that is a part that's going to remain. Left click. I can now move over to the other circle. I'll select the arc. I'll select this arc. This is what we're trimming to. And then select the part of the circle that you would like to keep. And just work your way around the profile that way. So select the arc, the part of the circle that you would like to keep. Select the arc, and then select the part of the circle that you would like to keep. And once again, this would be a good time for me to save my work. But before I do that, I'll select OK. And then I'll select File Save. How's everyone doing?
Good.
Nice. From here, I'll go back to the project page. Let's draw in the circles, the 0.375 diameter circles that go through the part. And we can place them at the center of the existing arcs, or we could place them on the corners of the rectangle, or we can place them on the corners of the construction rectangle. I'm in the wireframe tab, or from the wireframe tab, select circle center point. In the diameter field, 0.375, hit enter. I have my values locked in place, so I can create multiples. Once again, I'll lock onto the corners, or in this case, you see it locking onto the center. Either one will work. Place the 4 circles, and then select OK to exit the tool and save your work. I'll go back to the drawing. I'm going to use the rectangular shape tool again. We're going to draw this rectangular, it's like an elevated boss with a pocket inside of it. We're going to draw a rectangular shape that measures 4 inches. Let me zoom in a little bit. I'm looking at the outer edge of the rectangular shape. I've got 4 by 3. And it's got a corner radius of 0.6. So 4 by 3 with a 0.6 corner radius. I can do that inside of the rectangular shapes tool. So I'll go to wireframe, rectangular shapes. Origin is still at the center for the width, 4 by 3. I'll check that value. So 4 by 3. And I can also put the corner radius on it this time. So go to fillet radius. So under the height, you'll see fillet radius 0.6, enter. I'll let my cursor lock on to the origin. Double check the values, 4 by 3 by 0.6. Select OK. I no longer need this construction rectangle. You could put it on a level and keep it. I don't need it, so I'm going to delete it. So I'll hold the shift key down. I'll select one of the lines that represents the rectangular shape. When I shift select it, all connected entities become selected. At this point, I'll hit the delete key on my keyboard and I'll save my work again. And I'll go back to the drawing. Different things we can do from here. What I'm going to do next is I'm going to offset the rectangular shape that we just created. I'm going to offset it inboard a distance of 0.15 inches. 0.15 typical, that means this wall thickness is constant all the way around, or typical. I'll go back to Mastercam. We're going to use the offset tool. Now you can find this in two locations. You can go to transform and you can find it here, or you can find it under the wireframe tab. So wireframe, far right, offset. If I expand it, you have offset entity, you have offset chains. We're going to offset the chain in this case. So I'll select chains. That brings up the wireframe chaining dialog box. If it's set to solid in your case, select wireframe. I have C-plane selected, and then the selection method is set to chain. I'll select one of the entities that represents the rectangular shape. The entire profile becomes selected. From here, I'll select OK. Mastercam is asking me to indicate the offset direction. I'm going to pick select on the inside of the rectangular shape, and it offsets the profile inboard. Now, sometimes it'll be a smaller value. So if I change this distance to 0.15, it can be confusing which one is the original and which one is the offset entity or the copied item. A way that we can tell the difference between the two is the original will be red, and then the result will be purple. I need to flip the side that I'm offsetting to. I need the original or the red geometry, the red chain on the outside. The distance is 0.15. I'll select OK. Because we used a transform type tool, we have temporary colors assigned to the original and to the result. To clear the colors, right click on your screen. From the flyout menu, you can select clear colors. From here, I'll select save. How's everyone doing?
Good.
All right, great. Any questions up to this point? All right. Let's go back to the project page. We need to create a 2-inch diameter circle centered at the origin, and we also need to create the rectangular shape that represents the outside profile. The outside profile, or the large rectangular shape, will measure 6.5 by 4.25. Let's create that next. So I'm back inside of Mastercam. From the wireframe tab, I'm using the rectangular shapes tool. So underneath rectangle, rectangular shapes. For the width, 6.5. And then for the height, 4.25. I'll have to zero out the fillet radius. I don't need a corner radius at this time. I move my cursor into the graphics area. I see a preview of that rectangular shape. I'll let my cursor lock onto the origin. Left click. If everything looks good, double check the values and then select OK. Good time for me to save my work. The last thing we'll need to create, as far as the 2D geometry is concerned, is the 2-inch diameter circle. From the wireframe tab, circle center point. The diameter is going to be 2. I'll move my cursor into the graphics area, let my cursor lock onto the origin, left click. I'll select OK, and then I'll save my work. Now this completes the 2D representation of the part. If I go back to the project page, let's double check the instructions. All right, so for the modeling part of the module, let's see here. It says, using the drawing above, generate a 3-dimensional model using the Mastercam software. Use tools from the wireframe tab to create a 2-dimensional representation of the part. So step 1, we just completed. Step 2, create the standard levels that we will be using in this class. So next thing I need to do is bring up the level manager and create the standard levels, and we'll start placing things where they belong. So back inside of Mastercam, to bring up the level manager, I'll go to View, In the manager section, I'll select levels. I'll reference the project page to get the level names. Level 1, double click in the name field. And this one is going to be called solid support geometry. Everything that's currently on my screen will be used to create the solid model. So I'll call this solid support geometry. Level 2, that'll be our solid model. So to create a new level, I'll select the green plus sign, double click in the name field. We'll call this solid model. Level 3, wireframe from solid. Select the green plus sign, double click in the name field, wireframe from solid. Level 4, dimensions. Green plus sign, create the new level, and then name it dimensions. Let's see here, level 5, points. Level 6, material. And level 7, we'll call it name. Everything that's currently on level 1 is solid support geometry, so I don't need to move anything around. I'll make the dimensions level the active level. I'm now going to dimension the part to verify that everything is correct. I'm also going to change the wireframe color. So go to the Home tab, set the wireframe color to red. It allows me to see, or it helps me differentiate between solid support geometry and dimension geometry or dimension extension lines. It puts us on step 3. Use the Smart Dimension tool to dimension the two-dimensional representation of the part. I'm going to be referencing the drawing. I'm going to dimension it somewhat like we see on this top view right here. It doesn't need to be exact. I'm going to get it close, but it doesn't need to be exact. This is strictly for verification purposes. I want to make sure that this 2D representation of the part is correct. I'll start at the lower left corner and I'll work my way around the part in a clockwise direction. So let's start with the 0.75 and the 0.875 dimensions. I'll go to the drafting tab, Smart Dimension. I'll select the left vertical line, and then I'll select the center of the lower left circle. Pull the dimension off of the part. Place it. If you place it, then you realize that you need to change some things to it. You can select it again, and then come over to the decimal places. You can increase the number of decimal places. You can reduce the number of decimal places. You can increase or decrease the size of the text. It's entirely up to you. And I'll actually select it again, and I'll set the text height to 0.15. To place the 0.75 dimension, I'll select the bottom horizontal line. I'll select the center of the lower left circle, and then I'll pull the dimension off of the part. I'll create the 2.75 and then the 14-inch radius and the 0.15 typical. I'm not going to put the typical in there. I'm just going to dimension it at 0.15. So the distance from center to center, 2.75. I'll flip the arrows to the inside. I'll dimension the radius. Hit the A key and it flips the arrow to the inside or the outside. And when I flip it to the outside, it's a little bit cleaner. I don't have the arrow line going all the way to the center. So I'll flip it to the outside, then I'll place it. I also have the width or the 0.15 typical dimension. So I'll select this vertical line, and then I'll select this vertical line, pull the dimension off of the part. The next thing I'll do is I'll create the 0.6 dimension, and then I'll create these three horizontal dimensions and this radius dimension. To dimension this arc, don't lock on to the midpoint, don't lock on to the endpoint, just get your cursor close to it. When you see it highlight or become highlighted without locking on anything, left click, and then pull your dimension off of the part. The overall length, I can select this line, pull the dimension off of the part. To flip the arrows to the inside, I can hit the A key on my keyboard. The distance from, let's go here, center to center is 4.75, and then from end to end, or this edge to this edge, is 4. So center to center, 4.75, and then from this line to this line, I've got 4. The radius of this arc, select the arc. Once again, yeah, so I'm going to actually use this type of dimension. Just try not to overlap any existing numbers. It helps us see things a little clearer later on. So I've got the 6.5, the 4.75, the 4, and the 9. Over here we have another radius, and then we have 2 more vertical dimensions, a 3 and a 4.25. Zoom out a little bit. And the view for the 4.25, I'll just select this line, pull the dimension off of the part. I've got this arc. We'll call that, and actually I'll flip the arrow to the outside. And then from this line to this line, flip the arrows. I've got 3 inches. I've got the diameter of these 2 circles, this radius, and this radius, and that should do it. So the diameter of the circle. Once again, I can flip the arrows to the outside. Diameter of this circle. I've got the radius of this arc. And then I've got, let's see what else we have. Oh, it looks like I double dimensioned this one. So this 0.6 is also down here. We only need it once. So I believe I've got all the dimensions covered. I'll fit my screen. I'll zoom in a little bit. And this would be a good time for me to exit the drafting tool and save my work.
Hey, Pat.
Yes, sir. So now that I've dimensioned the part and verified that my 2D representation of the part is correct, I'm going to make the solid model level the active level, and I'm going to make the dimensions level invisible. I'll go back to the project page, and I'm going to scroll down to the instructions. We're now on step 4. It says use the extrude tool to create a solid model of the part. All right. Anytime I start giving a part depth in the Z, I like to look at it from an isometric view. So on my graphic or in my screen or on my screen, I'll right click. From the flyout menu, I'll select isometric. I'm going to extrude this so that the 2D representation of the part stays on the top. And my origin will also stay on the top. Even though we're going to create a new origin, the origin will stay on the top. and the 2D representation of the part will also be on the top of the solid model. If I look at the drawing, we're going to extrude the outside rectangular shape. Well, there's several ways to do this, but I'm going to do it one of the more direct ways that I've come across. So I'll start by extruding the base feature. That'll be the outside rectangular shape, and we're going to extrude it for a distance of 1 inch. I'll go to solids. In the create section, I'll select extrude. Brings up the wireframe chaining dialog box. Once again, mode is set the wireframe. C plane is selected, and then the selection method is chain. Select one of the lines that represents the outside rectangular shape. All connected entities become selected. I'll select OK. And you can see that we're extruding in the positive Z for a distance of 1 inch. Those are default values. I'm going to change the direction of the extrusion. The distance of 1 inch works in this case. And I'll select OK to exit the tool. And I could have stayed in the tool, but I'm going to change the solid color. I want something that's a little bit, I want a different color than what I used for my solid support geometry. I'll go to the Home tab. For the solid color, I'm going to set it to this yellow color right here. Actually, I'll use this orange color. To change the color of an existing item inside of Mastercam, left click on it, and then select the color icon. It's going to change it to the active color. So I'll demonstrate that again. So let's say my color was this blue color. I wanted to change the color of this solid model. Select the solid, and then select the color icon. Whatever the active color is, that's the color that the part will change to, or the geometry will change to. So I'll set it back to orange, select the part, and then select the color icon.
You extruded 1 inch, right?
Correct.
Okay.
And I extruded it in the negative Z. I'm keeping the solid support geometry on top of the model. Okay, from here, we're going to make a series of cuts. I'm looking at the area between the outside edge and the profile that consists of all arcs. I'm tracing it with my cursor. So what I want to do is I want to remove the area between the outside edge and the profile that consists of all arcs. If I look at this section view, the depth of that cut is going to be 0.63. The distance from the top of the part to this step right here is 0.63. I'll go back to Mastercam. I'll go to solids. So solids, extrude. I'm going to use 2 chains to make this cut. I'll select the outside edge, and then I'll select the profile that consists of all arcs. I'll select OK. This time, instead of using create body, I'll use cut body. And we're going to set the distance to 0.63 and then hit enter. If everything looks good, select OK, create new operation. It brings up the chaining dialog box again. We're now going to select the next set of chains to use for a cut. We're going to select to remove the material in this region, the region between the arc profile and the outer rectangular shape. So when I say outer, I mean the two that have the 0.6 radiuses on them. So I'm going to select this chain and this chain And this will be a cut for a distance of 0.36 given to me by this dimension right here. So I'll select this chain and this chain. I'll select OK. Set the distance to 0.38. Everything appears to be correct.
0.36 or 0.38?
0.38. Did I
Okay.
say 0.36?
Earlier you had, but all right, thank you.
Yeah, no problem. Yeah, so 0.38. The first cut was 0.63. The second cut is 0.38. And I'll check my values. That is correct. From here, I'll select OK and create new operation. We need to make 3 more cuts. I'm going to cut the inside rectangular pocket. The inside rectangular pocket is cut to a depth of 0.5 inches given to us by this dimension. So I'll select the inside rectangle. I'll select OK. Set the distance to 0.5 and hit enter. If everything looks good, select OK, create new operation. Brings up the wireframe, brings up the chaining dialog box again. We're going to cut the circular pocket next. If I go back to the project page, the cut is to a depth of 0.7. So select the circle, select end selection, and then set the distance to 0.7. If everything looks good, once again, OK, and create new operation. We need to make one more set of cuts. We're going to select all 4 of the 3/8 or 0.375 diameter circles. Select OK. Set the distance to through all. And then select OK, hit the green check. We're going to exit the tool at this time. I'll look at the part from an isometric view. Something I want to check. I want to double check this 0.63 value. I might have transposed some numbers or entered something incorrectly. If I go back to my managers, go to view. In the manager section, select solids. Inside of the solids manager, if I expand it, you can see all the different elements that we use to create, or all the different operations we use to create this solid model. The second one, the second cut that we made was used to make this step. I want to double check the depth on that one. So select it. With it highlighted, right click, go to edit parameters. And I'm checking the distance, and the distance is 0.63, so I'm okay with that. I'll select OK to exit. And then you'll notice that this operation stays highlighted. To get that to deselect, select the top level solid. From here, I'll exit the solids manager. I'll look at it from an isometric view. I can make the solid support geometry level invisible. And this would be a good time for me to save my work. So now that I've created the solid model of the part, I'll go back to the project page and let's see what we need to do next. We are now moving on to step 5. Use the curve all edges tool to create the wireframe representation of the part. Make sure that your construction plane is set to 3D. Go to the home tab. We're going to change the wireframe color again. We're going to change it to something that we haven't used yet. I'm going to set it to like this dark blue right here. Actually, that might not be a good color. It might conflict with the background. So let's go with I'm gonna use this rust red right here. From here, I'll go to wireframe. We're going to use curves, curve all edges. With my version of Mastercam, I need to triple click to select the solid body, and that's a little tricky. So triple click anywhere on the part. And when you do it correctly, the entire part becomes selected. With the entire part selected, select end selection. It appears as if the edges have become highlighted and Mastercam is creating geometry on all the solid edges of the part. From here, I'll select OK. And you can now see that there are 95 entities, and that is a mistake on my part. I go to, so instead of hitting undo, there's more value into moving this geometry, moving all the wireframe geometry to the correct level, the wireframe from solid level. I should have made the wireframe from solid level active first, and then created the curve all edges geometry. So let's do this. Make the wireframe from solid level the active level. On the far right of your screen, you've got these selection filters. Upper left of this icon, the fifth one down, select all wireframe entities. Left click. Once everything becomes selected, go to the Home tab. In the Organize section, you'll find Changed Level. So Home, Organize, Change Level. I'm going to move all the selected entities to level 3. And in my case, because it's the active level, I could just use the Use Active Level checkbox and select OK. If I turn off the solid model level, you can see I have a 3D representation of the part built from wireframe geometry. I like to have the solid model level visible and the wireframe from solid level visible, and I'll keep the wireframe from solid level as the active level once I create all the geometry that I'm going to need. We're not done doing that yet. Let's see here. We need to create the material and the name. Let's see what we're instructed to do. But before we do that, save your work. Let's see here. So we just did step 5. Use the curve all edges tool to create the wireframe representation on the part. We did that. Step 6. Use the create letters tool to create your first and last initial on the bottom center of the circular pocket. Reference drawing for size of text and location. I don't know if we have that on the drawing. Let's see. Yeah, there's no note indicating the size, the text style and height. So what we'll do is we'll use Mastercam box font, and let's set the text height to 0.5 inches. So I'll go back into Mastercam. I'm going to place the initials off of the part, and then I'm going to move them to the center of the bottom of the circular pocket. Before I create the initials, let's change the wireframe color again. I'll set it to this blue. We'll see how it looks with the orange background or the orange part. I'll go to wireframe, create letters, create your first initial and your last initial. For the style, I'll use Mastercam box font. And for the height, set the height to 0.5. Once you hit enter after entering the height value, move your cursor into the graphics area and you'll see a preview of your initials. I'm going to deliberately place them away from the part. So left click to place them and then select OK. I'm now going to move these initials to the center of the circular pocket, the bottom of the circular pocket. To do that, I'll use the transform tool. I'll go to transform, position, translate. You can window select your initials. Select end selection. I'm going to use the vector from to. Right below that, you'll find an icon or a button that says reselect. Select reselect. Then I'll zoom in and I'm letting my cursor lock on to the center point. Left click, rolling my scroll wheel, zooming out. And now I'm going to zoom into the circular pocket. I'm going to let my cursor lock onto the bottom center of the circular pocket. When I see it snap into position, left click. Set the method to move. And then select OK. I'll fit my screen. I'll clear the colors. And you can see the initials well enough on the bottom of the pocket. From here, I'll look at it from an isometric view. I'll fit my screen and then I'll unzoom by 80%. It's also a good time for me to save my work. Now that I've placed my initials, I'll go back to the project page. Step 7, use the bounding box tool to create the solid representation of the material. Okay. Make the material level the active level. Change the solid color. So I'll go to home. For the solid color, I'll set it to, say, this color right here. Go to wireframe. We're using the bounding box tool, so bounding box. To select everything on my screen, I can do a Control A. With the part selected, I'll select end selection. And right away, it's creating an envelope that captures everything that we selected. So, and the way this project works out, the part is already to size, or the material is 6 by 5, 6 by 5 by 4.25 by 1 inch. So double check these values. And let's go back to the blueprint real quick. In the notes, it says make from a 6.5 by 4.25 by 1 inch thick piece of aluminum. So I'm checking these values, 6.5, 4.25, 1. That's all good. Go down to the bottom where it says create geometry, deselect lines and arcs. This is something I forget from time to time, so I just want to emphasize that you need to deselect lines and arcs, select solids, and then select OK. I can't see my part anymore. The material representation is overlaying it. So what I'll do is I'll make the wireframe from solid the active level, and I'll make the material level invisible. If I need the material, I just make it visible. For now, I'll toggle off the visibility of it. I'll look at it from an isometric view and save my work. If I go back to the project page, scroll down to the instructions. Step 8, create a new coordinate system and name it first operation. To do that, I will make the material level visible again. We could place it at any of the corners. For starters, I'm going to place it down here, upper right corner, bottom of material. Reason being, one of the first things that we're going to do when we machine this part is we're going to machine away this corner. And if I place my origin on any of the top corners, the origin will be machined away. And if for whatever reason we have to put the part back on the machine, we're going to have to create a new origin or get creative placing the origin. So I'm thinking in this case, I'm going to place the origin right here. We'll call it upper right corner, bottom of material. To create that new coordinate system, I need to bring up my planes manager. I'll go to view, managers, planes. This was one of the questions on the test that we just took. Can you create a new plane inside of the Mastercam software? Yes, you can. To create a new plane, I'll select the green plus sign, create a new plane. We're going to select from solid face, and we're going to pick the top face of the material. It starts by centering the new plane or the new coordinate system on the face that we selected. The options, we have 8 options to select from. Z will always be perpendicular to the selected face. And let me turn this, I'm changing to a translucent mode for a moment. Watch what happens when I cycle through these options. Z will always be perpendicular to the selected face or the selected flat face. It can be perpendicular from 2 directions. So that's why we have 8 options. Watch what happens as I scroll through this. We're pivoting about the Z. And then it flips over and then it pivots about Z again. So those are the options that we have as far as orientation is concerned using this method of creating a plane. In this particular case, I like this orientation. Positive X is running this way, Y this way, and Z is going up. I'm not worried about the placement yet, just the orientation. I'll select OK. Name it first operation. To replace it or to relocate it, select reselect. When you move your cursor into the graphics area, you'll see a preview of the coordinate system. I'm going to let my cursor lock on to the upper right corner, bottom of part, left click. You'll see the new coordinate system being placed at that location. From here, scroll down. I'll check set as WCS, T-plane, and C-plane, and then I'll select OK.
Sorry, what'd you just do?
What I did was hold on one second. I checked WCS. Let me pull it back up. So from solid face, select OK. These down here where it says set as WCS, T-plane, and C-plane, I checked all of those.
Okay.
All right.
Thank you.
You're welcome. Okay, so from here, I can turn off translucency. I can close out of the plane manager for now. I can make the material level invisible. I'll look at my screen from an isometric view. I'll fit the screen. I'll unzoom 80%, and I'll save my work. I'll go back to the project page. That completes step 8. Step 9, save the Mastercam file as matching parts core to the project folder, also named matching parts core. We did that once we did a significant amount of work. I don't like to lose work. So anytime I do something, anytime I got a little bit of time invested in a project, I want to make sure that I save my work. So step 9, basically that should take place after each step in the modeling process. So we're done with the modeling process. Next class, we will go into the creating of the tool paths. So once again, back inside of Mastercam, make sure you save your work one last time.
Pat.
Yes, sir. I'm sorry. Yes, Lydia.
No, it's okay.
My bad.
Your name isn't in the name field, just to let you know.
My name is not in the name field.
The entity, like your
Oh,
initials.
thank you very
Yeah.
much. Let's fix that. So the geometry for my initials is on the wrong level. And here is an example of why you want to assign different colors to things, because now I've got a bunch of wireframe geometry visible on my screen. I've got a solid model on my screen. I can't come over here and select all wireframe geometry because it picks up on everything. So what I can do, I can come over here and I can select things by color. So select all entities by color. I click on this upper left half. It brings up this dialog box. It's only going to show us colors that are currently visible on my screen. So color 82, I'm going to select it. I'll select OK. They all become selected, or the initials become selected. Now I can go to the Home tab, Organize, Change Level. And I'm going to move them to level 7. This time it's not the active level, so I'll deselect use active level. This number field becomes available. I can type in 7, hit OK. And now my initials reside on the name level. For the time being, I can make them invisible, get them out of the way for the time being. And I'd like to keep the wireframe from solid level, the active and current level. That way I can easily turn things on and off. So from here, once again, I'll look at it from an isometric view and I'll save my work.